Hello, we are in F4 Circles, and this is the overview. There are actually 4 total videos in this section that we will be covering, and this one's just an overview of the whole section in itself. The second video will cover 7 through 20 in the book, and 21 to 42 will be the next one, and then the last one will cover a couple problems in the applications. Everybody's favorite, the word problems. And but this one right here will be the overview of F4, and what I'm going to begin with is the definition of what a circle is, and then we're going to talk about the standard form of a circle and the standard form at the origin. So some circles are centered at the origin, so that's one of the special cases. The unit circle, we'll talk about that, and then we'll give the general form of what a circle would look like, and those are more or less for formatting purposes only. It's just kind of, this is what they are. And sometimes you want to put the answers that way, and you don't use it very much, but it is there. And so the definition of a circle, what is it? Okay, well, I want to keep it to you kind of in the line of what a geometry definition would be. What the one definition of a circle is, it's a set of points on a plane that are equal distance from a fixed point. Okay, and that's what a circle is. All right. Now, the reason it says on a plane, the set of points on a plane, it's because if you don't have that word in there, it's a sphere. It's three-dimensional. So the plane's like on a surface. So you have a fixed point, and then you have a set of points around it that are the same distance. So that's what a circle is. Now, what we're going to do is we're going to put this on an XY plane, or what we call the Cartesian plane. And this set of points itself is actually a circle. The point that's the fixed point that I kept referring to is what we call the center. It's the center of the circle. Okay? And it's the set of points that are equal distance. That equal distance is called the radius. So that's some kind of diagramming what the definition is. So this is the center, and the distance to a point on that circle is called the radius. Now, a circle's definition comes from the distance formula that we learned back in F1. It doesn't look like it should be, but it is, because what it is on a circle, let's say this one here, and we're going to call it point H, K, just for convenience. Okay, and then these points around it are a certain distance, and let's pick a point that's arbitrarily on this, so it's X, Y. Now, yeah, why do we call it HK? It's just formatting. It's something that's kind of a historical thing that they've always used HK, and that distance there is called R. Now, how do you find the distance between X, Y, and HK, but using the distance formula? Well, the distance formula is going to be distance equals the square root of the difference of the x coordinates, remember from F1, plus the difference of the y coordinates. And so since I'm not using x1, x2 here, I'm using x's and h's and k's, I'll use that format. So the distance is equal to the square root, difference of the x's, x minus h, squared, plus the difference of the y's, y minus k, squared. And then, but what is that distance? Well, that distance is r. So the d is actually r. That's what we call the distance between those 2 points, the radius, which is r. If I squared both sides, the radical goes away. And it ends up in using symmetry again. It's x minus h squared plus y minus k squared equals r squared. And that is the formula to find this, the equation of a circle. And it comes from the distance formula. And that's the standard form. So standard form is x minus h squared plus y minus k squared equals the radius squared. So that's the standard form. So if you know the center of the circle, and we'll be doing some examples in a bit that talks about the center and the radius, and you just kind of use it and just plug it into that formula, and you have the equation. And remember what the equations are for. Equations are used, and why do you want the equations? To find more points than you already have. So if they give you the center and they give you the radius, then you can find a lot of points around that are the same distance from that fixed point, that center. Now, the standard form at the origin is just a special case. So if you're at the origin, then the HK is at 0, 0. So in this particular case, HK equals 0, 0. So it's just a matter of plugging 0 in for the H and 0 in for the K. So it becomes x squared plus y squared equals r squared. So sometimes you'll see the equation of a circle looking like that. And so it's x squared plus y squared equals r squared. And then you ask, well, where's the h? Where's the k? Well, they're not there. So if they're not there, then the h is 0 and the k is 0. So it's centered at the origin. So now sometimes they'll make one of them 0, but not the other. For example, they'll have something like x squared plus y minus 2 squared equals 4. So in this particular case, the h is 0, but the k is 2, not negative 2. Notice the formula. It's x minus h squared plus y minus k squared equals r squared. The center is at the hk. So you can't just look at the number and say, okay, it's a negative h and negative k. No, it's not the way it works. So in this case here, the center is at 0, 2. Now I always do a little mental thing in my head to figure out what the h and k is. I don't always remember what it's plus. It's always plus or it's always minus or whatever. I just look at it this way. What makes it 0? What makes that one 0 is 0. What makes this one 0? That's 2. So you can think of it as the opposite of that number if you want. That's one way people remember it. Other ways people remember is the way I just showed you, is just determine what makes the two terms 0. 0 makes this one 0. 2 makes this one 0. So and whichever works for you, stick with that. Keep with that concept and don't switch back and forth with those. Get with one, let it work for you, and stick with that. So you can either take the opposite or of the terms or determine what makes it 0. Your choice. And then the radius, remember the radius has to be squared out here, so r squared in this case is 4, which makes the r 2. So what does that look like? Well, it's a circle. It's centered at the point 0, 2, and the radius is 2. And we'll do a lot more of these once we get to some of the other problems. And so now my point is all this equation right here, every point that I just drew on the circle satisfies that equation. That's the whole point of drawing the equation. So if I want to know where are the points if x is 1/2, I plug 1/2 in here and solve for y. And if I plug 1/2 in here, which is about right there, whatever I get there, I'm going to get this number here for the y coordinate, and I'm going to get the y coordinate that's up here. I'll get 2 answers. And you do? Yeah, you do. Because when you plug in 1/2 here, you'll square and get 1/4, and you move it over here, and that's like 3.5, or 3 3/4, something like that. And then you have to take the square root of both sides. The moment you take the square root of both sides, it takes the plus or minus. Remember, square root property. If x squared equals a, then x equals plus or minus a, square root of a. And so the same thing here. So you'd have to take the square root of both sides, and then that tacks on the plus or minus. So that's why you get a number down here and a number up there. And when you add 2 to the other side, it probably pushes above the x-axis. So, but anyway, that's why you get those 2 answers. Now, but that is when the circle is centered at 0, 2. You'll have all different possibilities. And again, we'll do a lot more problems in the second, third, and fourth videos here. So, now the unit circle is just a special circle from this one. Okay, it's x squared plus y squared equals 1. So it's not just a circle centered at the origin. It's a circle centered at the origin with radius 1. So if you have a circle that's centered at the origin, and it can be anything, it's just the standard form at 0, 0. But the moment you made the radius 1, it's called a unit circle. So basically we're going from more general to specific. So this takes care of all of them. This is the ones that centered at the origin. This is centered at somewhere in a quadrant maybe. This one's centered at the origin, plus the radius is 1 as well. So it's more specific. Now the general form though is basically, it's just a formatting thing, is making sure what they look like. So basically if you multiply x minus h squared out, you FOIL that one out, and you y minus k squared, you FOIL that out, to rearrange some terms and stuff like that and set it equal to 0. You'll have an x squared and you'll have a y squared. And then you'll have a number in front of the x, and you'll have a number in front of another y, and you'll have a constant, and you'll set that equal to 0. So it looks like this: x squared plus y squared plus ax plus by plus c equals 0. So yeah, where does the a, b, and the c come from? That's just general terms. So if you had, for example, x squared plus that y minus 2 squared equals 4 that we had over here, that example I just gave you, if I multiply all that out, we have x squared plus y squared minus 4y plus 4 equals 4. And instead of equals 0, I get x squared plus y squared minus 4y equals 0. So in this particular case, there is no x term, so a is 0. By, so the b would be negative 4, and c would be 0 because there's no constant term there. So, but sometimes if there's like an x minus 3 squared here, then there would be an x term. But this is more of a formatting thing, and a lot of times though, they'll give the equation to you in general form, and then you have to reverse up back to standard form. And why you got to do that is so you can find the center. The process of doing that is called completing the square, and again, I'll talk to you more about that one in a later video here. So, but on this video, the main thing I want you to understand is the formula that you're going to have to memorize. Okay, x minus h squared plus y minus k squared equals r squared, and remember where it comes from. The distance formula, as you recall, the distance formula came from the Pythagorean theorem in a previous video that we did. So the Pythagorean theorem gave us the distance formula, and the distance formula gives us the equation of a circle. So, and then the standard form, x squared plus y squared equals r squared, and then the unit circle. So these are just special cases, and then the general form is when you multiply everything out. And like I said, a lot of times they'll give it to you in that format. So, all right. Thank you for watching.